behind this project ranges from an engineering lab where someone might want to work hands-free while needing constant data measurements from their devices, or to a more serious role such as a medical room or maybe a surgeon operating on a patient wants measurements from a heart rate monitor or something of that nature right in front of them at all times. So at this point, I'd like to introduce our team. Ryan Liu is our LabVIEW specialist. He worked to develop all the virtual instruments needed for this project. Eric Smachi is one of our Google Glass developers. He worked on code design and analysis. Kimmy Long is a Google Glass specialist. He worked on the implementation and also the debugging of this project. And finally myself, Carl Todd, who developed the interface between these two components of the project and also led the team. So as some of you may know, the current iteration of Google Glass was actually discontinued this year in January. However, the next iteration of Google Glass promised to have better processing power, better battery life, and also better heat dissipation. What this actually allowed us to do was focus on some of the concerns that were brought to our attention from last semester. One of the first concerns was the actual setup of our device, since the Google Glass does not have your standard touchscreen or anything like that from what you're used to on a tablet or something of that nature. However, what we did first is to satisfy this was create a very easy-to-use interface. So essentially we implemented both voice commands and swipe gestures so anyone could easily navigate through our application. The next thing we did was we wanted to make the application as easy to set up as possible. So in order to accomplish that, what we did is eliminate any dependencies for external devices. That means you simply need our LabVIEW virtual instrument and our Google Glass application. There's no data interpreter between the two devices, and there's no dependency on an Android paired device either. The last thing we want to do is make sure that setup was even easier. So essentially all you have to do is run the virtual instrument, run our application, and the signals are automatically detected and begin communication between the two ports. Now, the other thing that was brought to our attention was the actual heat dissipation last semester. Now some of you may know that Google Glass has heating issues in its current state. So to address this, we actually decreased our frame rate and increased our latency as well with a few other minor details to make sure that our device can run safely and reliably in its current iteration. However, we look forward to the future iteration of Google Glass solving some of these issues so we can increase that frame rate and provide an even better user experience. However, we feel confident in our current iteration of the project and find it's very easy to use. However, we look forward to development of future iterations of Google Glass. With that, I'd like to open the floor for questions.
Questions? Say something about the application.
I'm sorry?
Application?
Yeah, so basically the original motivation behind this project was actually specifically just for medical rooms. So we wanted maybe a surgeon to be operating on a patient, to have like a heart rate monitor and things like that right in front of it at all times. So he could, instead of having to like twitch up and look over at that screen, it would be right in front of him on that Google Glass heads-up display. Now here at UTDesign, we're a little bit limited on our access to some of those devices, so we decided to interface with LabVIEW. LabVIEW has the ability not only to interface with all these things like heart rate monitors and stuff like that in a medical setting, but it actually extends the application so that we can pair it with things like oscilloscopes, data, and different engineering equipment as well.
Just one more question. Latency in the system from data acquisition to presentation.
Yeah, so that spawns actually right now. So the lowest you